sorry, the author is unable to come here due to visa reasons, so she prepared a video.
Good afternoon, everyone. I'm Jiajie from Zheng University, and the paper I will present today is titled as Revisit Target Model Poisoning of Federated Recommendation, Optimize the Mode Objective Transport. And items. Previous attacks simply alter predicted scores on limited malicious clients, which disregards revising collaborations on the representation level. Local score promotion only affects limited clients or a group of similar users, failing to have a global impact on Federated. Besides, straightforwardly boosting scores of all targets also overlooks relations between targets, items, which triggers potential conflicts in the optimization. Second, attacking multiple target items with identical optimization objective ignores target heterogeneity. As the figure shows, target items may exhibit rich diversity, implying the need to generate distinct users to find the best matching between users and targets. For example, item V1 and V2 are liked by user U1 but disliked by U2, while V3 and V4 are exactly the opposite. To promote exposure ratio, poisoning targets on the users who initially dislike them is more effective. For example, poison V1 or V2 on U2, while V3 or V4 on U1. Previous attacks indiscriminately poisoning randomly generated users, neglecting target heterogeneity. The heterogeneity requires simulating more targeted users, thereby formulating discriminative attack strategies to achieve a globally optimal promotion. To address these issues, we propose a heterogeneous multi-target transfer attack, which aims at exploiting distinctive traits of targets and leveraging multifaceted user-item collaborations to tailor various attack strategies for optimal performances. Our framework contains two main stages. The first is diverse user agent generation, and the second is optimal multi-target transport attack. Now, let me show the details of the first stage, that is, the diverse user agent generation stage. Due to the inaccessibility of prior knowledge, the first stage for target model poisoning attacks is generating user agents purpose fully on malicious clients. Previous studies randomly construct synthetic users which overlook intricate collaborations between users with target items and the multiplicity of targets. Thus, we propose this stage to simulate discriminative user agents for downstream attack, which has two parts. The first part is collaboration-aware manifold learning. We construct a user agent space with manifold learning at first, and then measures the collaborative distance with affine subspace approximation. The second part is differentiable constructive sorting, which aims to enhance difficulty and diversity of agents. Here, we seek to select an agent group with high attack quality from the agent space. The attack quality is attributed from the first difficulty scale with regard to all target items, which decides the gain on exposure ratio. Second, the diversity scale, which facilitates the coverage of target items with heterogeneous properties. We develop a differentiable contrastive sorting, which first completes a differentiating agent selection process with isotonic optimization, and then employs a contrastive loss to strengthen the attack quality of selected agents from both scales. Then we come to the second stage, that is the optimal multi-target transport attack. Previous studies ignore item characteristics and user preferences, thus carrying out indiscriminate attacks. In contrast, we propose an optimal multi-target transport attack to formulate distinct strategies for different targets, leveraging limited agents to achieve maximum attack effectiveness. This stage has two steps. That is, the first, distribution mapping via optimal transport, and the second, hybrid multi-target attacking. The manner and extent of agents' involvement in local chaining determine the direction of poisoned gradients, which leads to varying degrees of exposure promotion for different target items. Thus, the insight of designing discriminative attack strategies for each target item is to reveal hidden matching between targets and agents. To achieve this task, we employ the optimal transport technique, which tackles the general problem of moving one distribution of mass to the another distribution as efficiently as possible, by giving out optimal solution of the coupling matching among typical anchors in two distributions. To adapt heterogeneous target items features, we develop a hybrid multi-target attack loss to resolve contradictions between local optimization directions, thus achieving global maximization of exposure ratio improvements. Hybrid multi-target attack has two aspects, that is, the first, future-oriented attack, and the second, preference-oriented attack. First, we reduce the feature bias between the agent group and the target item set, so that target items are endowed with characteristics that difficult users favor. With the optimal coupling matrix, we find the best direction of transferring agents from user space to item feature space. Thus, we propose the feature alignment loss to minimize the distribution discrepancy between agents and target items. Second, we directly reverse the preferences of user agents on target items, which implicitly modify the recommender parameters and item representations to transform target items from unpopular to popular. For malicious clients, we reduce the prediction score gap on user agents between target items and the items that they initially like. We conduct extensive experiments on 3 datasets to illustrate that our model outperforms various types of baselines. The results prove that our attack framework exhibits higher attack capability and stability encountering with the multi-target cases. To ensure the stillness of our attack, we further evaluate side effects that poisoning brings to recommendation performances of Federated. The results show that our attack produces insignificant effects on recommendation accuracy. We also conduct more ablation studies on two main stage modules of our framework to verify the effectiveness of the generation stage and the attack stage. To conclude, we propose a model poisoning framework against Federated from a new perspective, that is, to overcome the multi-target exposure promotion problem. Extensive experiments demonstrate the effectiveness of the attack, but also expose the inadequate resilience of current defensive methods in Federated. We plan to investigate more patent and targeted defense strategies against this kind of model poisoning attack as our future work to enhance the reliability of federated recommendation. That's all about our paper. Thanks for your listening. Due to the visa restrictions, I'm sorry that I cannot come to the site to report my paper. If you have any questions about this paper, please feel free to email me. Thanks very much.